In this video, we're going to look at some of the considerations when selecting and planning renewable energy projects. So first of all, we're going to consider the renewables resources, things such as the wind resource or the geothermal reserve in a given location. We're then going to consider technological developments which result in improved efficiencies, and there we can start to consider the financial viability of different renewable energy projects. We're going to briefly discuss planning permission and the role that environmental impact assessments play in that planning process. And finally, we're going to have an example of the life cycle of a renewable energy technology, and we're going to be looking specifically at wind turbines. So in an earlier learning outcome, we considered renewable resources and we looked at how we could determine what level of resource was available in different locations. We started by looking at solar resource maps, and in the UK, we noticed that the best region, or the region with the highest levels of solar radiation, was the southwest of England. So that would indicate that solar power plants are better suited to the south and particularly the southwest of England. Next, we considered the wind resource and we looked at wind resource maps. And the example I have here is an offshore wind resource map. Now, the way that these would be used would be to determine average wind speeds in different locations. We also see these for onshore locations, but it means that we can start to hone in on the areas where average wind speeds tend to be higher. And the final type of resource we considered was the geothermal resource or the geothermal reserve, which relates to surface temperatures at different locations. So on this map, once again, we saw that in the southwest of England, there tends to be a very good geothermal reserve. This would indicate that geothermal energy could potentially be used in these locations. We also see in the north of England a similar situation where we have relatively high levels of geothermal reserve, but still somewhat lower than in the southwest of England. Now, these types of resource maps provide an indication of different regions where different technologies might be appropriate, but that isn't a sufficient basis to develop renewable technologies for a given site. So instead, what we need is a full resource assessment, and ideally this should be conducted at the proposed site. Now, I'll give you an example. If we were planning an onshore wind farm, we would want to be collecting average wind speed data, peak wind speed data, but we would also want to be looking at the turbulence intensity of the air. All of these factors would determine how much electricity we could produce, but it would also determine the types of wind turbine that we would need for a given site. So there would be lots of different things to consider once we'd collected this resource data. Now, the purpose behind collecting this resource data is so that we can make a more accurate approximation of how much income our wind farm's going to generate. If they're not going to produce profit, then these projects are not going to go ahead. So we need a relatively accurate estimate of how much income the project's going to generate. So next we discussed technological developments, and we also mentioned contracts for difference, which is a type of incentive for companies to develop renewable energy technologies. So first of all, let's discuss the levelized cost of electricity, which is a way of comparing the costs associated with different energy technologies. So we looked at this image previously, and what we noticed, as we would expect, is that offshore wind is the most expensive technology to develop, and this is cost per megawatt hour of energy produced. So this is actually a ratio of cost to energy production. So offshore wind is the most expensive technology. Below that, we have our large-scale solar PV, which is the second most expensive at the present time. Then we have onshore wind, and finally, we have our gas turbine plants. So what this shows is that the fossil fuel burning plants are currently more efficient or more cost effective. We see a change in future years where the cost of gas increases as we run out of gas and as the reserves become harder to access. And we see that the cost of onshore wind and photovoltaics drops below the cost of gas. Now, these are obviously just projections, but it indicates that there's an incentive to continue developing wind turbines and to continue developing solar panels or solar power plant. Now once again, levelised cost of electricity can only ever be used as a rough approximation of how much a particular project's going to cost. Projects would need to go out to tender in order to get a more accurate expected project cost. So there's lots of different steps in the costing process, as there were in the process for establishing an estimate for income. So once we have a realistic expected cost for a project, and we have a realistic estimate of how much energy we're going to produce, we can then start to consider the strike price. So the strike price can be thought of as the actual income that a renewable energy power plant is going to generate based on its energy production. Although the energy generated may be sold for less in the wholesale market, the contracts for difference are used to top that income up. So renewable energy power plants have a more reliable measure of income. Okay, so we've looked at how much energy our site can produce, and we've considered the costs associated with developing that technology. We've also considered how much income the site's going to produce. So let's assume that the project is financially viable, it's going to produce a profit. The next stage would be to apply for planning permission, and depending on the project depends on who you're going to apply to. For onshore projects, you would apply to the local planning authorities in the given area, and for offshore projects, you would need to apply to the Crown Estate. And there's lots of different factors that would affect whether planning permission is granted and whether the project's allowed to go ahead. One of the more important factors is something called an environmental impact assessment. And environmental impact assessments look at a range of different impacts that a given project may have, and I'll give you some examples of this now. So the information we're looking at here is taken from a document called Environmental Impact Assessment for Offshore Renewable Energy Project. And this document is the property of the British Standards Institute. So over in the top left-hand corner, it says the parameters that are included within an EIA are dependent on the nature of the project and a number of specific parameters. The parameters considered relate to both onshore and offshore environments and typically include. So I'm just going to run through some of the items on this list just to give you an idea of how in-depth these studies need to be. If we pick up here on point B, one of the things that would be looked at is water and sediment quality. So we need to ensure that our project isn't going to affect water quality. It will also look at ecology. And by ecology, we mean, is our project going to upset any ecosystems? Terrestrial ecology relates to on land, marine ecology relates to the sea. So is our project going to disturb any habitats for animals? Is it going to impact on migration routes for birds or for sea mammals? So it looks specifically at fish if it's an offshore project and marine mammals, and it also looks at the impact to birds and other different animals. So there's lots of different considerations before the project can go ahead. On the right hand side, it might look at whether the proposal is in a nature conservation or a protected area, or whether it would impact on protected species as an example. If we jump down to point H, we have coast protection and flood defence. And again, this is important. Is it going to jeopardise any flood defences that are in place? If we think of this onshore, are our foundations going to affect drainage or anything of that nature? So again, lots of different considerations. For our offshore wind farm, we also have impacts on other sea users. So are we going to interfere with shipping lanes? Are we going to interfere with aviation? And the same is true for onshore projects. Is our development going to affect traffic and transport? Now, additional considerations might include the impact on air quality, noise, vibration, and visual impact. So there's lots of different factors to consider. And things particularly such as visual impact may well tie into socioeconomics. The grounds for people objecting to wind farms is most likely to be because of the visual impact or the noise that they generate. So this is a very thorough assessment of all of these different impacts and how it's going to affect the surrounding areas. So the environmental impact assessment is going to be used to support the planning process. So finally, it's important to consider the life cycle of a renewables project. And as our example, we're going to use the life cycle of a wind turbine or a wind farm. Now this diagram here shows the different stages in the life cycle of a wind farm. So first of all, in the top left hand corner, we have the pre-development phase. So we're identifying sites, we're carrying out investigations, and we're engaging in discussions with landowners as an example. In terms of investigations, we'll be conducting an analysis of the resources that are available at the given location. Next, we have the environmental impact assessment, as we mentioned, because no project is going to be allowed to proceed unless the benefits of the project are seen to outweigh any impacts to the environment. Next, we have design and development. So this is where we go into a deeper analysis of our wind speed and wind quality data. We can select our wind turbines based on this data, and different wind turbines have different classifications. And we then enter into the tendering process, seeking grid approval and so on. It's not until all of that's been completed that the construction and installation can take place. Now, once the wind farm's set up, it's going to have an operating life of 25 years for an onshore wind farm. So we only have a finite life for that wind farm. After 25 years, the land on which an onshore wind farm is located needs to be returned back to its original state. So that's another important consideration during the planning process. How easily can the land be returned to its original state? And after its operating life, we have decommissioning. So the turbines would need to be disassembled and removed from site. Foundations would need to be broken up. Cables would need to be removed, and so on. So again, it's another important consideration because it's most likely going to incur additional costs. So to summarise, in this video, we've looked at the selection and planning process for renewables projects. We've talked about how we can approximate the resources that are available at different sites so that we can estimate the amount of income we can produce. We've also talked about how we can approximate the costs associated with the project. Next, we discussed planning permission and environmental impact assessments that are used to assist the planning process. And we've finished by looking at the life cycle of a typical wind farm installation.